Hello and welcome to the Monday, February 17th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich and I'm recording from Jacksonville, Florida. Well, we got a couple of diaries from this weekend to talk about. First one by Xavier about interesting Python malware that displays a blue screen of death. Well, actually, not the real one. It's sort of a approximation simulation of one. Not 100% sure why they're doing this. A couple possible reasons are, first of all, tricking the user into rebooting the system, which sometimes could, for example, activate some payload. Also, there is an 800 number listed on the boot screen, on that blue screen. I did call it earlier, and it went to some kind of depth collection agency. Not really sure what it's all about. Could be that this used to be used by some kind of tech support scam as well. Or as Xavier suggests, maybe it's just a simple anti-debugging technique. Well, in a second diary, Xavier is talking about issues with volatile IP addresses. You hardly ever get a static IP address, in particular for any kind of consumer connection. And even if you have a static IP address, let's say you co-locate a server, you rent some kind of virtual server in a data center, well, you're not going to hold on to this virtual server forever. And that's sort of where the problem comes in. Xavier set up a new infrastructure for a pen test, meaning he set up a couple of proxies and systems like that on a newly deployed virtual server. That IP address that was assigned to that virtual server apparently had been used by another organization in the past, and as a result, his infrastructure now received these requests. This is an issue that keeps coming up where, for example, some name server records still point to IP addresses that are no longer used by the particular entity. This often sort of goes undetected because either that domain is completely unused or, well, the other name servers may still be working just fine, and it's never really noticed that one of these name servers doesn't really exist anymore. Really important to keep good inventories as to what IP addresses you're using and be agile here. So make it easy to change IP addresses. And this is really the same also for IPv6, IPv4. Affects both protocols because quite often you're dealing with these ephemeral resources that you set up, use for a while, and then tear down. Well, and then we have an interesting vulnerability in Postgres, the SQL database. When I first read sort of the headline, I thought, well, is this actually a real vulnerability? Because the way it was sort of described was a SQL injection vulnerability in Postgres. That doesn't really sound like a vulnerability because if you have access to Postgres, well, you can execute arbitrary SQL commands, so you don't necessarily need SQL injection. But the tricky part here is that Postgres, as part of their supporting library libpq, does provide a number of functions to escape parameters. And these parameters are not properly escaped if you're using these built-in functions in libpq. And that's really the vulnerability here. Exploitability is, I think, a little bit questionable. It does require you to do a couple of a little bit unusual things like creating commands for as input then for pqsql, the command line utility. Not really how I would write queries like this, but I'm not using Postgres that much. It has, however, already been exploited, and late last year we had the famous compromise of Beyond Trust that then led to the compromise of a number of government organizations, and apparently this vulnerability was sort of one of the key vulnerabilities being exploited there, so certainly something that you should update quickly if you are using Postgres and have any systems like this exposed to the internet. But again, this is this supporting library. So it's very possible that a web application that uses Postgres sort of as a backend, and I think that's kind of what happened here with Beyond Trust, assumes that Postgres does the right thing, and as a result, you're now vulnerable to a SQL injection without any fault of the developer of the web application. And then we have a good write-up from Volexity about recent social engineering-based attacks against OAuth. And now OAuth is, of course, one of these fairly complex authentication schemes, often used to delegate privileges to mobile applications, devices, and the like. And one of the complexities behind OAuth is that there are a number of different authentication flows that can be used in order to authenticate a device, an application, a web service using OAuth. The authentication flow that's being abused here, and apparently by some Russian threat actors, is the device authentication flow or device code authentication. This is something that you often see in input-constrained devices like smart TVs, and you probably have done it at some point where you try to connect an application, like some kind of streaming application, a device, to your account. The streaming application is telling you, hey, go to this particular URL, log in, and then provide this device code, which often is just a fairly short alphanumeric code. Then the device is being logged in to the particular account. Now, this scheme is not just used for streaming applications, but also, for example, for more sensitive things like video conferencing and such. And that's apparently where it's being abused here. The attacker is essentially trying to connect their device to your account. They receive the device code. Now, they are sending you a phishing email or an SMS, and that's apparently sort of the preferred method here, tricking you into entering that device code into your account, associating the attacker's device with your account. Interesting trick, and like I said, it's really more a social engineering, phishing kind of trick, but keep in mind, OAuth itself is not really phishing-resistant authentication. It really depends on what you're sort of putting on top of that, how you're actually authenticating to your OAuth provider, your authentication service here, and that's sort of being exploited here. According to Volexity, there's also sort of a longer pretense usually happening here, where the attacker first establishes some rapport with the victim before they actually then launch the attack. Well, and that's it for today. Thanks for listening. Thanks to everybody subscribing to this podcast. It's available on all of your favorite podcast platforms. Lately, I upped a little bit the game on YouTube. If you enjoy sort of more videos, something more visual with subtitles and such, so you have that available. Still working on adding some subtitles also to the podcast feed, so it's also available on other platforms. Any feedback is welcome. And as always, please recommend this podcast. Please leave good reviews. And at the very least, ever so often, click the 5 stars. And thanks. Bye.